Hey everybody, this is Kit Merker here from Noble Nine, and I'm here with my colleague Sergey. And we're just going to chat a little bit about what's going on in software industry and SRE. Hey Sergey, say hi to everybody.
Say hi, hello. I'm Sergey. I work for Noble Nine. I'm an engineer and a little bit in the product, and this will be fun.
Well, let's hope so. It's the first time we're trying this, so we'll see what happens. Hey, so we were chatting before, and I think it's actually an interesting thing. You've been in the software industry probably a bit longer than I have, although you're a very young man. But tell me what's changed, would you say, over the course of your career in software? What's changed the most?
It is driven by the fact that about 20 years ago, we started to see that the individual performance of the CPU is basically became about, let's say, 4 gigahertz, and we're not going higher. It's based on technology. So what industry started to see is basically individual CPU performance, more cores, and interconnected servers. While we went through that stage, we had a couple of other things in the industry, but what actually we see today, what actually happened is a cloud. We can call it cloud, which we pay for to run something, or we can call it as a concept where we can run different software components. And that cloud is horizontally scaled. And it has multiple subcomponents running or services running in this horizontally scaled large supercomputer, like huge supercomputer. And that's what changed everything. There is one more thing which changed a couple of years ago, let's say about 5 years ago. We started to run containers. We started to use light path systems like Kubernetes. Before Kubernetes, we had messes and we have some other older systems. But today, most of the modern development happens in a container-based environments. And they built in the principle that components okay to fail. It's basically just a principle that any pod, any node can fail and it will be healed underneath. So developers today dealing with such environments, and they have to understand it very well. Going back to my cloud experience inside and outside of the cloud, I can say that subsystems can fail and can fail miserably. And it's up to software engineer and a Devops to figure out what's going on with that and make it invisible to the customers.
So you're talking about something that's sorry to cut you off, but you're talking about something sort of counterintuitive, right? On the one hand, we all know that reliability expectations are going up, right? People, especially end users, and even now, like when we look at like the work from home, we're not doing this interview in the same room. We're working from home right now. Digital experience has gone up. We all trust and need to rely on the internet more, but you're saying that perhaps counterintuitively that failure is more acceptable than it used to be. And can you maybe explain like why that's the case?
Yeah, absolutely. So the principles of today's systems, because of the scale, because it is basically impossible to say that the computer server or cluster will be always available. But healing principles allow quickly rebalance and rerun software on other places. It's just because of scale. Every unit can fail today. But at the same time, as you mentioned, it's absolutely correct. Systems become more reliable because software and even data can move from cluster to cluster. It can move from server to server, and make sure that software on top of it continues to operate. I can give you an example, interesting example. It's been 4 or 5 years ago. I was working at Verizon, but I worked with the messes and Docker, not Kubernetes. And I was listening about Kubernetes because actually that's what happened. The Kubernetes is the future, and I was thinking it would be the future. So I was listening.
I know you're not just saying that for me. I know.
No, no, no. Well, aside from other things, working and be excited about this company, I love the Kubernetes and I love everything Kubernetes does. Anyways, I'm not going to tell you exactly what the company was, but I listened to the video a very known company, which did a prototype of POC, 9 months POC, and tried Kubernetes. What they said is this: sometimes it fails, but we don't even see it. It heals by itself. So that's what I mean.
Yeah.
Systems are self-healing, self-scalable. But if you think one step forward, it may introduce some problems and some really difficult challenges. But that's the way it is today. We're at a large scale. We can't use one CPU, a large scale. We don't want to have our own infrastructure. We like to run in the cloud most of the time. And a lot of technology today in the cloud. Even 5 years ago, it was like marketplace and something like this. Today, it's basically fully integrated, all kind of services in the cloud, and it's very appealing. As we know, we run in the cloud, for cloud and in the cloud. So that's what's going on.
So tell me, you talked about scale, and I think the scale question is a really interesting one because as we have more and more services in the world, right, that are running at large scale, like consumer services and other things. But there's also a lot of startups too. There's a lot of companies that are starting from nothing. And I mean, one thing that's changed from my perspective is now you can start a company without, making a big investment in hardware or building a data center or anything like that, right? We have so much at our fingertips. But I also have talked to developers who, they're starting small. And one of the concerns that I hear is like, am I over investing? Am I building too much infrastructure, or do I need to get prototypes out that are good enough? How do I kind of balance pragmatism versus planning for the future? How have you addressed that in your vast experience, Sergey?
So let me try to answer about, first of all, trying to develop not in cloud versus in cloud. Again, with Kubernetes today, you can easily build your little cluster of the old servers for free. They're very powerful, even 5, 6 years ago, and you can start building your software if you don't want to pay for the cloud. At the same time, in my experience, because I've been leading a number of projects, move between the Kubernetes deployment locally and Kubernetes deployed in any cloud is not a big deal anymore. We went through many stages. We tried to run C code on the same systems. We tried to run, have libraries to run under Linux and the Windows. And then we went to this little Docker paradigm where we run Docker everywhere. And today, actually, honestly, I've been observing this and it's very exciting. We can run Kubernetes anywhere. Now, I can tell you, once you scale, 10 servers, and once you go into the stage of close to production, you don't want to deal with running Kubernetes itself. So you will go to their clouds. You can scale the product based on what you need. You can descale it, so you don't need to pay much money. You can have multiple teams to develop to develop and to deploy and to try and run the same software. And basically, at some stage in the development, you will scale that for the customer. There's a very known thing that's going on, like November, December sales, and when we all, and hopefully we all will do, we'll spend a lot of money, and all the digital services to support today sales and everything else have to scale in November, December to, 10 times, 100 times. People say different things. Good thing to mention something about one of your points. In this particular era, with a certain principles, I will go back to PaaS and Kubernetes in the cloud. You can develop for the small scale, and you can, with the certain principles, immediately go to the bigger scale, because the environment of Kubernetes in the cloud gives you all auto or manual scale capabilities. This was never in place. Like you asked me before how it changed, and we touched on it a little bit. And engineers today work differently. They have to understand more. They have to pay attention to more things, but at the same time, they can manage things themselves. They don't need to go to a sysadmins and set up, networking and databases and things like that. Everything is done automatically in the cloud for them. So they basically manage the whole process. It's something about scale, as you ask. It's also something about what is not changing, what's already changed in the industry.
Well, so on that point, it's a very interesting conflict there, right? Between, on the one hand, you've got this sort of full stack pressure or idea, right? That hey, developers, engineers, they can do it all, right? They can try to do it all, but maybe they're not able to focus, or they're not as specialized, right? They may not have the depth in a particular area, and so whenever we look at these DevOps transformations or how the automation's evolving, I think there's an interesting difficulty, almost a paradox, right? Where on the one hand, you want to DIY and kind of take care of stuff yourself and be empowered as a developer. But on the other hand, there are specialized roles for a reason. What do you think about that conflict between that evolution in DIY?
So DevOps, original DevOps, is basically development and operations together. And I've seen early stages of DevOps, and the conflict was there as well. They try to blur and put together development teams working with the DevOps. But I've seen it's a little bit like system administration. Also, what you said is the full stack developers. It's evolution today, and yes, there is a conflict. And sometimes if you're full stack developer and you don't have millions of years behind you, especially old experiences, you may overlook lots of things. You're absolutely correct. And it's what also changed the industry. Engineers used to be concentrated on particular areas and very good about that. Very, very good. I can give you another interesting example. Many years ago when I came to this country,
Canada? Where did you come from?
I came from Moscow, from Russia, from Soviet Union actually. I ran away from Soviet Union.
Before the fall.
Yeah, some people say because I ran away, it basically dismantled itself, but this is a different topic. I have nothing to do with this. Anyways, I had a call after a couple of years working in the United States from a headhunter, recruiter, before internet, because job hunting and other stuff. And I kind of had a conversation. I said, what do you suggest me to do? And he answered, I suggest you to be a specialist in a certain area and just follow that and build on top of that. I found in my experience it very useful. I went left and right from networking, real time, embedded systems to storage to cloud and a lot of things. But that's how I want to answer your question, is that I always used to be built on certain principles, which I built many years ago. Today, sometimes it's not the case. Engineers today educated be full stack, and it's correct, but sometimes that's not enough depth, and it takes quite a bit to get things right. And sometimes, actually going back to the target of our company, to compensate for such things in the cloud when products are not 100% reliable, that's where, again, our company can help to handle the situation between the engineering, you can say DevOps or SREs, and management.
So for you personally, I mean, it sounds like you started off with this sort of specialist mindset, although then you quickly said you moved from specialty to specialty. So it sounds like you found kind of a strategy for how to approach that. How do you stay like when you're digging into a new specialty? I'm just curious, how do you actually keep yourself sharp? What's your approach?
It's a very interesting question. It's a very challenging question. So I try to see for the trends in the industry somewhere in the back of me. I can join the company, I can stay with the company short or very long, but I'm trying to find the trends in the industry which put me in the edge, absolutely edge. And somehow my experience gave me that all those chances to work on the cutting technologies from time to time. Of course, you have to move yourself. You have to constantly motivate yourself. And now you have to make choices. You can't cover everything. You just have to be useful in a certain area, understanding a lot, but also still be a specialist where you can make a difference. And I think every young engineer today likes to do that as well. We can see it in our team. People like to make a very big difference and dig into things, and so we can build a good product. Maybe that's the way to answer this question.
It's a good answer. What do you think about with, junior engineers starting their career right now and thinking about, all the stuff going on in the world, in the trends like you talked about, right? You've got cloud, you've got digitization, we've got remote work, future of work stuff that everybody's thinking about. There's so much to learn and there's so much experience to be gained, and the job market's competitive. Meanwhile, it seems like there's never enough engineers. We can never find qualified people, to fill the jobs that are vacant. That's a real challenge. So I don't know, what's your kind of sage wisdom to, the sort of, newcomers to the industry? What are your thoughts on that?
Well, it's going to be very precise because a couple of years ago, I was trying to help somebody I know how to restart after college. It was not successful. I didn't help him to restart. But I will say this: Go as a language, for example, and I've been working in embedded C, C++. I had very little tiny Java. I had some other languages, but Go gives people very good mix of preciseness of C and not object-oriented design, but some kind of a structural approach. I'm not going to say C++, but basic structural approach to things. It's good. Definitely cloud, Docker, and Kubernetes, no question. Absolutely no question. Today, it is a fact. I will see this to be going forward for years. I do not see competitive technology today, even like a function as a service, some other stuff. It has its applications, but core still needs to be in place. So Kubernetes, definitely Docker, understanding how this system works. It's basically how before we used to learn operating system. It is operating system today. And try to be very precise, try to be very, understand what you're writing and learn from your colleagues. Sometimes learn from people who know a little bit more. And be very much engaged with what your subcomponents is doing, how it works within a system, within multiple subsystems. That's what I used to do all the time, pretty much, even like years ago. If I used to be at the company just a developer, I will develop the subcomponent, I'll fully test it in a system and within a system with the system components or without them. So I think it's a great principle, and be ready to jump in and fix problems, be positive. Teamwork. Today, it's definitely distributed teamwork. It's respect. It's like not afraid. In industry before, it's like, okay, I'm afraid to be wrong. I was never, and I always used to say, oh, I made a mistake. It's okay. And today, with the teamwork, when we say, oh, yeah, this is great, I was doing something not correct, so the whole team and the solution can move forward. I think that's the principles. And again, of course, work with the cloud. If you like to join smaller teams of the low-level developers, network, some robotics maybe, or infrastructure, chip development, silicon development. As you can see, for example, Apple, for example, just announced what I've seen in this industry before, building specialized processor for the laptop. And it's a lot of this stuff around us. We just don't hear much about it. And junior developers are going out of college often do not hear about such jobs. But if you're really up for it and you want to build career on it, I think it's going to continue. It's also, but it's very challenging. If you're good in math, if you're good in digging into small things, go for it as well.
And so definitely on the sort of leaving college and sort of the hardcore computer science side of it, like you're talking about, for people who are maybe thinking about joining a big company versus a startup, what's your advice on that? Like the contrast between the two, what do you think? You've worked at both, so.
I've been very lucky. I'll tell you this. If you look at my resume, you will see very big companies and some of them for too many years, if you can look at the surface. But realistically, I always had an opportunity, even inside big company, to work in small groups. I will not say unmanaged, but I will say with the new targets in the industry, where we can work, I can even say this way, even less structured than in a startup. EMC was this way, any other company before that, startups and non-startups. I worked for Samsung for a year. It was basically a lab. For example, I worked for a couple of startups. I worked for Intel, where we're making absolutely new silicon. I was on the software side, which now you can see in the industry. As well as EMC was the same thing. So I believe, honestly, and this is also what's changed, that it's a good idea to find startup or the place where you can move forward, learn a lot, and be engaged and excited. Sometimes bigger companies with a, let's say, fix and run for maybe multi-billion-dollar products and profits may not give you such excitement, and that actually people don't like and they leave, especially at the beginning of career. So go for something where exciting is going to be. I mean, I cannot stay anywhere if it's not exciting. Let's put it this way. It's been known for years.
Yeah.
I'll tell you just another second. For example, I worked for EMC for about 10 or maybe a little bit more than 10 years. We worked, I will say we worked on multiple different projects, very difficult, which development had no time to do and no charisma to do. But 10 years for me is like 5 or 6 or 7 different, absolutely different projects. So you can say I started like 5 or 6 different startups, technically.
Right. Tell me just as we're kind of wrapping up here, I just have one kind of last question for you. What's one of the hard technical challenges that you're personally working on right now, without revealing any intellectual property secrets you can't share about what we're building? But tell me, is there any hard problem that you're working on right now that you think is kind of interesting that you've got knocking around in that brain of yours?
I'm going to answer it in a very strange way.
Okay.
So our product will be helping people to find where quality is not enough, if we can put it this way, right? And where performance is not enough, then functionality is not working because of the top performance problems. And based on everything we just discussed in the cloud and self-healing and some other stuff. So as of today, actually, and maybe a little bit less at the beginning, my biggest number of energy I'm spending is to make sure that we are above and beyond in our product of the standard quality, you can call it this way, or standard performance or something like that. So our product will be able to pinpoint what's going on with other systems, helping people and developers, as I said, managers, developers, call it Devops or SREs, come to the table and with precise understanding what happened, what will happen, what may happen, to tell and rely on our product. So again, that's what my that's where my energy mostly spent today.
I was hoping you'd say something like, trying to get the Docker environment up and running on your laptop or something, but
that's not a big deal at all.
Well, thanks, Sergey. I think we're about out of time. It was really fun chatting with you. Hope you enjoyed it. Did you have a good time?
Yeah, absolutely. It was always great. We can chat more if you have more agenda. Hopefully, it helps.
All right. Well, thanks a lot, everybody, for watching. If you made it with us this far, Kit Merker here from Noble 9 signing off.